Good morning, everybody. I'm Jo from STEMPOINT, and with us today we've got Chris Griffith, who is going to tell us all about studying a meteorite. Hope you enjoy the talk. Any questions, please let your teacher know, and they can put them in the chat. And there will be time if teachers want to come off mute to ask those questions. Over to you, Chris. Thank you very much.
Hi, morning everyone. Like Jo said, my name is Chris. I am a geoenvironmental engineer for Geoenvironmental Services Limited, but whilst I was at university, I had the opportunity to study a meteorite, and I've got a short presentation for you about that. So let's get started. So, what is a meteorite? A meteorite is a part of the meteoroid or asteroid which actually makes it to the ground. Not all meteors that enter the Earth's atmosphere make it to the ground. In fact, anything smaller than a football field will likely break apart in the atmosphere, resulting in a bright flare, which is what we see. I think there was one a couple of weeks ago, if any of you saw that. In total, over 60,000 meteorites have been found on Earth to date. I'm sure there are many more that have been undiscovered so far. So what happens when a meteorite strikes the Earth? The small ones can land on Earth without any incident whatsoever. Large ones cause things called impact craters. These are formed when the space rock hits the Earth under intense heat and pressure. The Earth turns molten around it and it releases a shockwave and rebounds back. So if you think about dropping a rock on sand at a beach, the rock hits the sand, which rises up around it and then falls back. And this is pretty much exactly what happens when a meteorite hits the Earth. In 2013, a meteor the size of a tennis court exploded over Russia, and the shockwave caused windows to shatter and injured 1,400 people. Obviously, the larger the asteroid, the larger the impact crater, and the effects such as shockwaves powerful enough to destroy buildings, seismic tremors, and even falling debris. But we haven't had any like that for a very, very, very long time. Once meteorites reach a certain size, it's thought that they hit the Earth with such force that the meteorite completely vaporizes on impact, meaning there's no space rock to find. And there are also online simulations where you can see what would happen if different size asteroids hit different cities across the world, if you're into modeling. So where do we find meteorites? We can find them anywhere in the world, mostly on the land, because the oceans obviously are very deep, so if they land on them, we're probably not going to find them. We have found some in the UK. If you just search meteorite finds in the UK, you'll see we've had many over the years. The other reason that meteorites are normally found on land and impact craters are found on land is because the oceans, the crust underneath the oceans are constantly being destroyed and reformed at plate boundaries. So any impact craters that are on ocean floor, the ocean plates are much younger, so the likelihood is that we wouldn't see them anyway, that have been destroyed at a plate boundary. But yes, so it's estimated there are 70 meteorites that impact every day, and most of the time we just don't hear about them because they come without any sort of issue. So what do they look like? That sort of depends on their origin and composition. So they can be stony, which means that they're pretty much made of silicate crystals, or iron, and they're mostly metal. Obviously the iron ones are a lot denser, so they create a bit more of an impact. Almost all meteorites that are found on Earth have come from asteroids. However, a small amount have originated from Mars or the Moon, where a bigger meteorite impact has blasted off bits of rock, and they've ended up, those offshoots have ended up coming up and hitting the Earth. Oh, too far. So, did you know that a meteorite wiped out the dinosaurs 65 million years ago? So an asteroid the size of Mount Everest fell from space and hit the Earth around Mexico. The impact was so massive that it formed a gigantic tidal wave and caused so much rock and dust to rise into the atmosphere that it caused the sun to be obscured and global temperatures to drop for many years. And this made it very hard for living things to survive. In fact, it wiped out 50% of all plants and animals on the planet. And the impact crater at Mexico is the second largest impact crater found on Earth. Something you might not know as well is that in the early stages of the formation of our solar system, roughly 4 billion years ago, there were lots of asteroid strikes on multiple planets and moons, and these craters are much larger than modern ones. It's generally thought that the moon was formed during this period of time when an absolutely colossal space rock that scientists named Theia smashed into the Earth over 4.5 billion years ago. This rock was so big, it's thought it was the size of Mars. And the Earth was still in its molten phase, and this means that the Earth, 4 billion years ago, the Earth was just all molten rock. We hadn't got our crust, we hadn't got oceans. It was just one massive molten rock, lots of lava flows everywhere, and the rock basically, the meteorite the size of Mars hit us, and so much material was ejected into space that it condensed and formed our moon, which I think is pretty cool. Also means that the moon, unfortunately, is not made of cheese, as some of us were led to believe. Sorry. So the largest impact crater in the world is known as the Vredefort impact crater. It's located in South Africa, and it was formed 2 billion years ago. It's roughly 300 kilometers in diameter, but due to its age, it's mostly eroded away. So the meteorite that made this impact crater was roughly 10 kilometers wide. It's not only the largest, but also the oldest known impact crater. And the effects of an impact crater are determined by the mass of the rock, the speed it's traveling, the angle of entry, and the descent where it hits. 70% of Earth's surface these days is water. And actually, although we've got a huge population, there are lots of areas on Earth that are sparsely populated. So even if a meteorite that big hit today, the likelihood is it would probably end up over water, because 70% of our surface is water. So which meteorite did I study? So there are roughly 200 known impact craters on Earth. And in 1994, an impact crater was discovered in South Africa. Now, this isn't visible on the surface, but was found using geophysics. In 2006, some scientists drilled into the crater and discovered a 25-centimeter fragment of original space rock that hit the Earth. The meteorite was found at a whopping 770 meters below the surface. So why is this meteorite important? As I mentioned before, scientists think that any large space rock that hits the Earth should completely vaporize on impact. There should be nothing left, because it hits with such force, such pressure, and such heat that it just vaporizes instantly. And this meteorite, this impact crater, is 160 kilometers wide. Therefore, we weren't really expecting to find any space rock, because we thought we wouldn't find anything in any crater that was over 4 kilometers wide. But we did, and that means that we can study it, and it means that it's a very exciting piece of rock, because it's the only thing like it in the entire world. So yes, this fragment is very unique. It means that this space rock is very different from the rock that it hit on the Earth. Their composition is very different, and they collided under super high temperature and pressure, and that can sometimes lead to the formation of different minerals. So there's a potential that a new mineral previously unknown to scientists is present where the space rock and the surrounding Earth rock have interacted. So we want to study this rock to find out if that's the case. So what did I use to study this piece of this rock? So part of the rock was sliced into a very, very, very thin section, and that meant it could be looked at with a microscope, the kind that you see scientists looking down on TV programs and that you might use at schools. So I also used a scanning electron microscope, and these produce images by scanning the surface of the thin section of rock with a focus beam of electrons, and the electrons interact with the atoms and help us get information about what they're made of. This is all a bit technical, but it's useful information. I also used X-ray diffraction too, and this is where X-rays are beamed to the sample and the different crystalline structures reflect the rays in different ways, meaning we can see the composition and crystal structure of the rock. Basically, I used lots of very, very high-tech equipment to help me see what was going on, help me look at the meteorite, help me look at the earth rock that it hit, and help me look at where they meet. So what did I find? Chondrules. So chondrules are small rounded grains of cosmic origin found in meteorites. These are some of the oldest in the solar systems. They're so old, they're older than the planets themselves. This means they can help scientists understand what the conditions were like in space all those years ago, and they can help us see what the building blocks and materials were like when the planets formed. And when studied, they can also tell a story of the journey that the meteorite has been on through time. So this is the chondrule here. You can sort of see it's spherical, and it looks very different to the rest of the meteorite rock. So this is a photograph down a microscope of the contact between the Earth rock and the space rock. So you can see here, this is the Earth rock. The Earth rock, the grains are a lot bigger, and there's a lot of silver looking minerals in here. These are feldspars. And then down here is a space rock. This is these grains are much smaller. And they're all different colors. And there's a lot of, these are the olivines in there. The brown bit in the middle is where the two meet, and they met under super high temperature and pressure when the meteorite hit the Earth and caused the minerals to change. And so this is the exciting part, because this is something that we've never seen before. So if you think about the interaction between these two, think about when you heat a bar of chocolate, it melts, yeah? So imagine if you heated a bar of white chocolate and heated a bar of milk chocolate and then squished them together while they were still hot. The resulting chocolate would be a little bit of white and a little bit of milk, right? This is sort of the same thing. The minerals from the meteorite are being mixed with the minerals from the Earth rock to potentially form different minerals. And because we've never seen anything like it, they could be new minerals, which is very exciting. So I compared the compositions of the minerals I found to known iron silicates, and they didn't match any of them. I sent them to a mineral specialist, and he confirmed that no iron silicates matched the ones that I found, which made me very excited because I thought I found a new mineral. Unfortunately, due to the quality of the thin section and the limited budget, we actually couldn't prove whether or not they were new minerals. But this means that that's still something left to find. You know, someone, when work starts again, they'll create a new thin section, they'll redo all the tests that I did, and they may find that they are, you know, they found some new iron silicates, which would be really, really exciting. But equally, because of the age of the thin section, it might just be that they were normal ones that we have known about and we do know about that are a little bit rare. But the quality of the thin section means that the numbers weren't coming out quite right, which could have thrown off the results. I really hope that they're new minerals, because that would be very exciting. So what does this mean? You know, what does this mean for the wider research area? Many other craters have not been investigated for meteorites and space rocks because it's thought there were none to find. However, the presence of space rock in Morocco means that there may be some after all. And hopefully it means that people might decide to go back to other impact craters and see if we can find some rocks there to investigate, so we can learn more. So what happened to the meteorite that I studied? The core of the meteorite has sat in storage for many years, but exciting times, because work will soon start again, trying to find what happened. And my project, because it was only an undergraduate, very small third-year project, wasn't published. So the only published data on this is from 2006 still. But yeah, work should be starting soon. Hopefully we can use a space rock to find out lots of new information about how impacts, affect space rock and Earth rock, and maybe find some new minerals. So it's not just meteorites, asteroids, and the moon aren't the only rocks that we can look at in space. Planets such as Venus and Mars have volcanoes on their surface, which is pretty cool. Uranus and Neptune both have rocky cores. Pluto is no longer classed as a planet, but it has an impact crater filled with ice made of nitrogen. Titan has lakes made of methane instead of water, which is crazy. And Mercury has no atmosphere, so asteroids don't break up like they do when they enter the Earth. So its surface is absolutely covered in impact craters. And the majority of known asteroids in our solar system are found within the asteroid belt between Mars and Jupiter. So there's a lot of rocks in space that we still, are trying to study, get more information about. Space is one of those ones where we don't know everything yet. There's still so much more to find. And there's so many rocks to study in space. So it's an exciting field. So I'll just go through a couple of important space rock events that have happened. I say recently. One of them is recently, one of them is not so recently. So in 2021, scientists from NASA launched a spacecraft that was set to collide with an asteroid. The idea was if you crash the craft into an asteroid, it could change the asteroid's orbit. And in 2022, the spacecraft successfully crashed and changed the asteroid's orbit. The orbit was changed by several minutes. And this means that if a potentially catastrophic asteroid was ever detected on a collision course with Earth, we would potentially be able to redirect the asteroid so it went past us rather than hitting us, which is pretty impressive. It's thought that an asteroid over 100 kilometers in diameter would be large enough to potentially cause an extinction level event. Luckily for us, scientists know where most of the space rocks that size are, and none are on path to Earth, so we should be good. So the other one that's not quite so recent was the Rosetta Philae, I think it's called Philae, spacecraft. So the European Space Agency, in 2014, the European Space Agency launched a spacecraft that would meet up with a comet orbiting the sun. This craft would spend 2 years with the comet on it and send back valuable data and images to the scientists. A probe was successfully landed on the comet and sent back data for 57 hours before running out of battery. So the European Space Agency had a team of scientists working on the data sent back to help us understand more about comets, which leads us into careers and jobs that you can get studying space rocks. A lot of these are research-based, so you could be a PhD student with a planetary geology basis, or a postdoctorate position, or a lecturer, or you could work for the European Space Agency. So there are quite a few sort of planetary and space-themed PhDs and postdoctorate research positions available. Obviously, those change year on year as to what's actually available. But yes, European Space Agency employs geologists to analyse data and samples for meteorites, the moon, and other planets. So careers looking at space rocks with the European Space Agency. So these are just a few of the titles that you can that geologists and geoscientists play in the European Space Agency. So planetary geologists research the geology and composition of the planets and our moon. They also look at surface processes and mineral composition of rocks from space, and can be integral to designing, planning, and executing missions which involve taking rock samples. Astrobiologists look at geological environments in space which could support life. Geophysicists study the physical properties of rock bodies in space, including magnetic and gravitational fields and plate tectonics. Geomorphologists study features of planets and moons to understand their formation and evolution. Remote sensing specialists use satellite imagery and remote sensing data to study the geology and surface of other planets. And sample curators manage and study the samples returned from space missions, such as rocks from the moon and meteorites. So there's a lot of rock-based jobs in space that people maybe don't realize exist. And I love that, to be honest. I love that there are all these different jobs that you can do from a geology degree, studying space rocks. I think it's awesome. So I am not, sadly, I am not I'm not a space rock geologist. In my fourth year, I actually decided to go into something a bit more practical. So I became a geoenvironmental engineer. That means I test soil and rocks before building starts to make sure they're suitable. Some rocks are better to build on than others. Some soils are really soft, and if that's the case, you have to change the foundations. So the foundations are like these concrete anchors that just keep the buildings in place. So I go to any building site that I'm asked to go to, and I dig holes and test the rocks and soils, and yeah, come back with results, make reports to my clients to tell them whether or not they can build on it as it is, or whether or not it needs some sort of work on it to make it suitable. Oh, I think I just skipped one. So if you want more information, you can get it at the European Space Agency, spacecareers.uk, and the Geological Society of London. These are all really good resources for things like careers or job titles, or how to get into the careers that you want to look into. Yes, thanks for watching. Any questions?
Thank you so much, Chris. I think I learned a lot from that. And there was certainly a lot of terminology that I hadn't come across. So just a question for the school that have attended. I know we've recorded this, but I'm just wondering, Chris, if you're happy, if we can share this presentation with them, because I think there might be bits that they might want to go back to
Yeah.
sort of explore and delve into. Is that okay?
Yeah.
And
Shouldn't be an
would
issue.
would that be happy?